Hi everybody, today we're doing piecewise functions, section 3.4 of our notes. We are going to graph them and then we're going to also write them from a graph. So let's get started. There's going to be two different parts to it. So on this first part, we're talk about what a piecewise function. A function made up of several pieces from different functions is called a piecewise function. So probably should write that over there. All right, piecewise function may or may not. So just kind of make sure that you keep that in mind. It could be either one of those. We just want to make sure that we feel that we understand whichever it is we're doing. So it may or may not be continuous. We talked about continuous earlier in this unit. Okay, in other words, it may have breaks or gaps in the graph. So let's start first with graphing piecewise functions. And here are some tips. There's obviously more than one way to do this. I like this way because I think if you're a visual person, it really helps you to see actually what is happening and what we need to do with the graph. Okay, so first you want to do is you want to visualize each piece and identify its transformations. Using a pencil, graph each piece without considering the domain restriction. Afterwards, erase the portion of each piece of the graph that is not in the domain. Number 3 is check that you graphed your endpoints of the domain restrictions correctly. The symbols of less than and greater than are not included in the domain and use an open circle. The symbols less than or equal to or greater than equal to are included in the domain and used a closed circle. So let's kind of go through the steps as we look at each one of these at this next example. So we have here two different types of equations here. Remember, you can always write this as y equals, okay? If the f of x is bothering you when it comes to graphing them, that's fine. But I want to look at each part as we talk about it. So the first one right here, I write this number 1. My graph is y equals x minus 2. And this is linear. So in order to graph any linear line, it's in slope-intercept form, so we look for the slope, which is 1. It's that number that's right in front of this x. And look at the y-intercept. Well, this -2 part right here tells us, so we have a negative slope, a negative intercept at 0, -2. Okay, so it tells us that we need to graph it. So let's just graph it. Don't worry about what x can or cannot be for right now. And so I'm going to go to my graph. So I'm going to graph it and start back up. Okay, so I've graphed my line here. Now what I want to look at is the second part. Use a pencil, graph each piece without considering domain. Afterwards, erase the portion of each piece of the graph that is not in the domain. So we want to look at what our domain is. So the domain restriction is what's given after they write the function. So as you see here, what's written after the function is that x has to be less than or equal to 1. So if it's less than or equal to 1, so when we're talking about 1, we are talking about when we start right here. Okay. But less than is towards 0, going towards the left. Okay. So it means all the values from here to the left can be used, but not anything to the right. So for us, that would be right here. And anything to this side of it, we're going to get rid of. We're going to keep. So let's get rid of the other side that we don't want by erasing it. And so we erase everything down to that 0, okay? Let's get rid of this extra stuff here. Okay, and the last part says on here, number 3, check that you graphed your equations with the domain restriction. Okay, so we have this less than or equal to in our actual problem up here. So therefore, that has to be a closed circle according to this and what we've learned before. So that's a closed circle. So I'm going to kind of make it more obvious that it's a closed circle. I need to know that I can see that, so therefore I can tell if it's open or closed for you. Okay, so now let's go to number 2. The second part, I said number 2. the second part of the graph. So the second part of the graph, or the function that given the second part of the graph we need to do, is we're looking at this part here. I'll call this number 2. So number 2 is y equals x squared. Well, that's a quadratic. One thing about the quadratic, we have 5 points that I'd like for you to know. So what I'm going to do is I'm going to plot those points. And if I know where those points are, that'll help me to graph my function. So let's plot those and draw the graph. As you can see, I plotted my graph. These are the points that I'm talking about, that are the ones that I want you to know. Okay, but again, we go look at the domain restriction, which is this right here, and we're saying x has to be greater than 1. So again, at 1, everything to this time but to the right is what we get to keep, everything else we erase. So let's do that. Now, I can get rid of this part too, but now what we want to look at is an open circle at that 1 or close? Well, according to this right here, it's not having a sign underneath it, an equal sign to it, so it's greater, so it's going to be open circle. So again, make this look like an open circle. If you need to erase it and draw it again, but make sure that we know this is an open circle. Okay, and then now that's done. This graph point right here should be there. We're done. Okay, let's go on to number 2. Okay, number 2, we have 2 functions here. And again, I'm going to write this so that it can help me. As a y equals, I have 2 functions. Here's my first one, my second one. The first one is x plus 1. That's linear. That is nothing new for you. You've been doing this for a while. My second one, I'm just going to go right here, over in our room, is also linear. So it's y equals, my first one, negative 3x plus 1. Okay, so we know here we have a slope of 1 and a y-intercept at 0, 1. Over here we know we have a slope of negative 3 and we have the y-intercept of 0, 1. Oops. So now what I want to do is I want you to draw those 2 lines, and I'm going to draw the first one and then I'll come back and then we can erase it and see how it looks. Okay, this equation is drawn. I have an angle here. I'll just put my lines here. Now, my domain restriction for this one is x is less than 0. So at 0, this area here, I cannot have anything to the the right of it because it's less than. It's an open circle because it's only less than. It's not less than or equal to. So at that point, I will change and erase what I don't need. And make sure at x equals at 1 there, I have an open circle. At 1, okay? This arrow should be going down this direction so we knows it's going on forever and ever. These are some points that we had on that line. Okay, so I want you to graph the number 2 and tell me, and then come back and see if you erased the right part. Okay, so if you see here, this is my graph. I had to get rid of what was, because it was going that direction. Up here, I had to get rid of that. And because x was greater than or equal to 0, everything to the right of it was saved, wasn't erased. And then at this point right here, there is a closed circle because of this symbol here. So make sure you realize that this is closed. It should be closed. I should see it closed. It shouldn't be partially open and partially closed because one was an open circle and one was a closed circle. Okay, once it's being used as a point, it's there. It doesn't change. Okay, so let's try 3. All right, so this one has 3 different functions. So I'm written them down and separated and put the domain restriction underneath. Okay, so this one, number 1, it's a cubic. And so what we want to do, what happened is this shifted up one unit. Okay, so remember, knowing the parent function was really helpful and that you don't have to keep relying on what it looks like. So we know that the parent function points, or the important points, are these right here. And if I shifted everything up 1, this is what it will look like. So let's just choose a different color. Everything is shifted up 1. So no, I'm going to erase this. Okay, so now when we graph it, remember it's like an S. That kind of curves up like that. And it's going through these points right here. Now, according to our domain restriction, X can be less than 0, and that's it. So anything that's on that Y-axis has to be erased. And on this one, because it's less than only, then we're going to create right here at the 0 an open circle. Okay, again, make sure I can tell that it's an open circle. And this graph should be going down. Okay. So our second function is an absolute value function. This is reflected over the x-axis because of that negative in front. So this is your absolute value. It is also shifted to the right 3 and up 2. Okay. So what I like to do, I personally prefer to do the vertex part first. And then reflect that from there. Okay, so because I moved over 3 and up 2, my vertex, which should be at 0, 0 is going to go 1, 2, 3, up 2. But because I'm reflected over the x-axis, every other point will be down like this. And I'm going to just draw some extra points. Sorry, that's not correct. So that we can see where the graph is going, making sure that we cover the entire domain restriction that we're allowed to have. Okay, so one thing nice about, you can use rulers, whatever you need to graph. Need to have a little bit extra up here at the top. Okay. So now that is the absolute value reflected, shifted over 3, up 2. Now, the thing is that we are bounded by this right here. That part right there does not let you go anywhere else. So what we need to do is we need to change to figure out on here what's at. So I get to go to 0. X is between 0 and 2, and there's both included, so those are going to be closed circles. So I'm going to erase anything that's over here. Oops. Up to that 2 and down over here to that 1, because that's where 0 is. So between 0 and 2, I have this little segment. And then this segment right here has to be closed circles. So make sure I can again tell that they're closed circles. That's all that you get to use that part. That's it. Nothing else. Okay. So now let's look at the last piece. The last piece is a quadratic. Okay. The quadratic is shifting. So this is a quadratic. It is shifting this way 2 and then up 1. Okay. So my vertex will shift over, will be 2, 1. So I know at 2, 1 I have a vertex, and I'm right on top of this one. 1, 2, 1. Okay. And then I'm going up this way 1, this way 1. And I know that I get to be greater than 2 only. So if I draw my graph, kind of like draw it just down here, I see that I can only be to this right of this. Make sure you have a nice smooth curve. Make an arrow. That's definitely a value right there, you know, but it's closed right here because the other one is equal to. All right, so last one on this page. Again, we have 3 equations that we're going to have to write. And so this one will be, this first one is a constant, so y equals -2. This is a constant. Its restricted to be and x is less than -1. The second one we have is another quadratic. So it's number 1, number 2, 1, 2, and 3. It's quadratic, so we have our quadratic. The function is written y equals x minus 2 squared, quantity squared minus 6. It's restricted between, so this one's bounded. Bounded, we don't have that extra errors going off. And the next one we have is a square root. And its restriction has to be greater than 3. Okay, so let's figure out how these look. And look at their transformation. Always helps to make a graph quickly. So this is a constant. So at -2, down here, you have a constant. It doesn't change, it stays the same. Whatever y is, it's always going to be a -2. So I'm trying to do as I can. I'm just going to go a little past this. I have an arrow here and an arrow here. So this one, though, my restriction is x has to be less than -1. So at -1 here and to the right, we're going to erase. So when x is -1, and because it's just less than, that will be an open circle at -1. All right, next we have is a quadratic. We know that the quadratic is shifting this way 1 and down 6. Okay, so when we draw that, I always draw the vertex again. I know it's a 0, 0, but if I shift over 1 to the right and down 6, 1, 2, 3, I kind of line it right there. Okay, but onto this, to the right and to the left, we know it's 1, -1. So if we look at, if it's at 2, 4, 1, 2, 3, 4, original one. So we go over 1 and down 1, 2, 3, 4, 5, 6. Okay, and this side would be the same because it's symmetrical. So it goes over 2 here, so it's going to go here. And it is included because it'll equal 2. So here's my quadratic. And just so happens my shifting and my points end up at 1, 3. And those are closed circles. Last one, square root. So with the square root, we are shifting again this way to the right 3 and down 2. So if I look at my parent function, I'm going to erase this other parts. I'm going to go, my vertex starts at 0, 0 again, so it has these points right here. And so if I shift over 3, 1, 2, 3, down 1, 2, I wind up here. And this point winds up here, and our other point winds off, so we don't quite get it, but actually it winds up right here. Going to go down 1, 2, and over 3. Okay, so now to connect that, and we know that it has to be greater than 3, so it's going to the right. Make sure that you don't cross until here. So I cross there, there. Now erase the extra points. All right, so that's our drawing our piecewise functions. The next part we have is writing piecewise functions. So it's write the pieces in order from left to right as they appear in the graph. Use what you've learned about transformations of the base graphs and or writing equations of lines from Algebra 1. You've learned it in Algebra 2. To write each of the pieces, write the domain of each piece as an inequality. Each domain piece should begin with an x or be bounded by 2 values. So for A and B, use each graph to evaluate the function as the indicated variables and write the piecewise function. So this first one we have here is, we have piece 1 here. Oops, let me go to the writing part. And this is number 2. Okay, number 1 is a cubic. So if you kind of look how it curves. So a cubic that is positive would go like this. So here's these 2 points, this point here and this one here. And it's shifted and also reflected. So let's see what that looks like when we draw it, write it, and then we just have to figure out where parts go that are open and closed circles and so forth. So the first thing you want to do is you want to draw this nice little, do an f of x equals, and a nice little thing like this. Brace, what I call it brace. That's what it's called. And so we know that this function is a cubic. This is a cubic. It's reflected over the x-axis. Over the x-axis. Okay. And it looks like it also shifted to the right 2, and it looks like it went 1, 2, and down 2. Okay, so it's reflected. It's a cubic, but if this x value is in here, it's messing with it. So we're going to do x minus 2. Don't forget it's a cube. Minus 2. Spelled axis wrong. Okay, but what's the restriction of the domain? Remember, this is unbounded. Okay, it's going to go on forever and ever because that arrow. So that means we only have a variable and then which way it's going. These values are less than this. That's 2, so they're less than, but it's an open circle here, 2. The second part we have here is a absolute value. It too is reflected. And if you look at here, it went, this is where it would start, 0, 0. It went over 5 and up 1, 2, 3, 4, 5, 6. So it went to the right 5 and went up 6. So the reflection tells me it's a negative. The right 5 tells me I have to do inside the absolute value. I have to do x minus 5. Close that, I got absolute value sign, and then I'm going up 6. So now let's look at our domain. It is restricted. It is bounded between this value and this value. Well, this right here is a 2, and this is a 9. It's got a closed circle here. So remember, you write the number first. So it's 2 less than or equal to x because it's a closed circle. This is open, which is less than 9. This next graph has 3 parts, 1, a 2, and a 3. The first part is a quadratic. This part over here, the second one is a constant. And this one is an absolute value. Okay, so I'm going to write my big f of x. So if my first one's a quadratic, it is reflected. So this is reflected. And it is shifted up 1, 2, 3, 4, 5. It did not move left or right. So it don't have to write that part. So quadratic is just reflected over the x-axis. So that makes this the negative out here, reflected over the x-axis. So we take it to the next x squared. This up 5 plus 5. Now, it's unbounded, okay? So we have to think about how to write that. So it starts here, or not starts here, but it looks like it's going to end right here. So everything from the 1 to the left is allowed, but 1 has an open circle. So I'm going to write that x is less than 1, but not equal to. So it's got to be written like that. Second one, we have a constant. We know if we kind of carry this across this way, across the x-axis at 1, 2, 3. So we know it is going to be x equals 3. It's bounded at 1 here, and it's bounded at, looks like a 3 here. Okay, closed circle to begin with. So x, oh, excuse me, 1 less than or equal to x, which is less than 3. The last part we have is an absolute value. This absolute value has been shifted this way 5 times. So over 5, it's not done anything else. So we write the absolute value of x inside minus 5 because it's affecting the x value. And it starts at 3 and it's a closed circle, but because it's unbounded, it's just going to be x is greater than or equal to 3. All right, here we have two functions, and here we have some stuff happening. So this first part we know is a line right here, okay? So we're going to have to draw an equation, so we need a slope, write an equation, and we need the y-intercept. Well, this y-intercept is at 2, and this slope, well, the thing about this one here, let me zoom in as much as I can. This is showing you that this arrow is going on. It's clunky, it's big, but it's not crossing here at that one. It's going to keep going. If you were to actually put a ruler down, you're going to cross there. And this is at 8. So really paying attention to what's happening, -8. You'll see that where it's happening when we do things, we have to kind of make sure we're really precise on that and just think, well, what it could be. We're not estimating. It really actually is going there. And so we know if we want to find the slope, this is going down to, so m is -2 over this way 8. Okay, and that's a -8. So my slope is 1/4. So when I write my equation, I'm writing f of x equals 1/4 x plus 2. Remember, this is y equals mx plus b form. Okay, now what's the domain restriction? Well, it's going all the way over here. That's 1, 2, 3. That's at a 4. Okay. So, but it's less than. It's an open circle, and it's unbounded. So that means I have a variable. It's open. Sorry, wrong way. Less than at 4. Okay, let's go to the next one. The next one is a constant going forever in one direction. If I go draw it this way, it's going to cross at y equals 1. So this is a 1. And it starts here at 4, and it's closed. So x is greater than or equal to 4. And that's right there. All right, our next one. I want you to look at this carefully. I'm going to do some highlighting on here. You have 3 different things happening here. This is an equation that's going like this. It's a line. The next one is a quadratic. It starts here, comes around, and goes all the way down here. And the last one we have is a constant. It's just going straight across there. So we have three different ones, okay? So this is like your calculator, knowing that the ends are always going on forever and ever. They don't do that on your calculators. This is what's coming from. So this actually goes this way, going that way. So here, what you need, again, this is linear. So you always need a slope and the y-intercept. Well, we slope, if we go from here to here, and we know that's that way, so we're going down 1 over 1. So that means -1 over -1, so the slope is just 1. If we have the y-intercept, if you were to keep drawing this and we know the slope is 1, that means we go up 1 over 1. We wind up here at b equals 2. So we write that, it's y-intercept form, so we have x plus 2, and it's restricted, starting at this -1, excuse me, and it's less than, and it's less than or equal to. There's no holes in this at all, so it's going to be x is less than or equal to -1. Number 2 is a quadratic. There's your quadratic. The quadratic, it's reflected because usually they start here and go in this direction. That does not do that, so it's reflected, so that makes, we have that negative. It's reflected over the x-axis, and it shifted up 1, 2, so it went up 2. So we write it with a negative, so it is -x squared and a plus 2. So now let's see where the restriction is. Well, it's bounded. It's bounded like right here to right here. So we're not going to have x greater than or less than. We're just going to have it two numbers, and so forth. So we're starting at -1, and it's less than or equal to x. Again, no open circles. And this stops here at +2, less than or equal to 2. And the last piece we have is a constant. This constant, again, if we draw this way, that's going to cross at a -2. So we just get to write -2. And then it is starting at this x equals 2. Again, it's also closed, so but it's unbounded, so it's going to be x is greater than or equal to 2. Last part. Now what we want to do is we want to take these values and we're going to find out which part of the graph we get to use. When you're restricted, it's got to be very careful which one you get to use. So I have 3 different functions here. I have a function here that's domain restricted here. Another one where it's domain restricted here. And the last one, domain restricted here. Very important to know which one we have there. So when you look at each of these values that we're trying to find, remember these are always telling us that x equals this. This is what x equals. Okay? So for letter A, I'm saying that x equals -1. So if you're trying to figure out where I put this in, if x equals -1, x equals -1, this is not equal to, it's just less than, but there's the equal to here. So we're going to put it in the square root 1. So to kind of help myself, I'm just going to highlight which one I'm going to use, so I'll know which one I'm actually putting it in. So I'm putting it into the pink one, which is the square root function. So I'm going to use the square root function. So f of -1 equals the square root of -1 plus 1 equals the square root of 0. The square root of 0 is just 0. So this solution up here is 0. Let's go to B. B, I'm saying x equals 0 now. So back to what we were doing earlier, 0 doesn't fit here. 0 is greater than 1. 0 doesn't fit here because 0 is less than 3. And they're saying, so it's again going back to the square root function. So we're going to put it in this one right here. It's going to go there. So now in place of x, I'm going to put a 0 this time. Can use square root. So f of 0 equals the square root of 0 plus 1, which is the square root of 1, which is just 1. So the solution there is 1. All right, let's try the last one. The last one is when I'm saying x is greater than 3, but here I'm saying that x equals 3. So C is when x equals 3. So when x equals 3, which one do I get to use? Again, this has a 3 here, but again, it's less than, it's not equal to, so it must go into this one. So we're going to go into the rational function. Okay, so that one is the orange color, or yellowish color. So for me to, I'm going to put, oops, wrong one, thought I changed it. So it's going to go in that one. So I'm going to use the rational function. I just keep forgetting to change that back. So we're going to use, oh my goodness gracious. So f of 3 equals 3 squared plus, that's a minus 4 over 3 plus 2. So that is 5 over 5, which is 1. So this also is 1.